Okay, today I'm going to be talking about cryptography. I'm going to go over the three major ways that things are encrypted. I'm going to go over examples of how to do it, and I'm going to go over the complexity and how many different combinations there are of each type. I'm going to be encrypting PC Popper and showing how it's done in the different ways. First one we start off with is the Caesar cipher. It was used by Caesar himself. It's a basic shift cipher that just takes and moves text along. We'll have our alphabet here, and then what we do is we just shift each by 3, like this right here, where A is now D, B is now E, and so on and so forth. So what you do is you just take your letters, when you shift it over, you just find where the new letter is, and then you just take and encrypt you write down the new letters, which in this case would be S, F, S, R, S, S, H, U, and that's your encrypted thing. Now the complexity of this is there is 26 combinations, which means that it's pretty easy to crack. All you have to do to crack this is just use a simple frequency chart, and you will see that E is used most often. In this case it's not, it's P is, so this will give some problems. But otherwise, that's the easiest way to crack it. So based upon that, what we're going to do next is we're going to try to reduce the frequency of each letter used. To do this, they came up with what's known as a polyalphabetic cipher. This is also known as a Vignier, excuse my pronunciation of it, cipher. It was actually invented by Giovanni Balasso in 1553. This uses a simple key phrase, such as Darren in this case. Then it figures out for each letter what is the number that's associated with it. In this case, 4, 1, 18, 18, 5, 14. And then it uses that to shift each individual letter that many times. Unfortunately, because my key is shorter than my actual length, you have to start repeating it, which leads to it being able to be broken by just using a simple shift and just keep and to figure out how long the actual key is, then you can use that. In this case, there are 6 letters in my key text, which means, as far as I know, that it's 26 times 6 combinations, or 156 total combinations. There's a little more processing power that it would take to crack this one compared to the Caesar cipher. However, it can still be cracked easily. Finally, they came up with a one-time pad. This was developed by Frank Miller in 1882. It's commonly attributed to a patent in 1919 by Gilbert Vernon. However, that was a patent for XOR one-time pad. The way this is done, instead of using a preset number of keys, such as Darren above, the key is a series of randomly generated numbers that is as long as the text you're trying to encrypt. This makes it harder because there is no set frequency, there's no repeat, or there's no repetition or anything. So in this case, you take each number, and as a Caesar cipher, you just shift your letter that many times for each letter. In this case, T, H, X, G, B, Y, J, K. The complexity with this one is it is 26 to the 8th combinations, which is a little over 208 billion combinations. Now that would take a lot of power to have to try to compute that, and it's pretty much uncrackable. That is why they call the one-time pad the perfect cipher. Thank you for your time.